Yeah. Now we are going to see about sequences. So sequences. So these are also treated as database objects. Okay. And so generally we create sequence. We create sequence in order to generate values, okay, in a cycle or no cycle. That means, in other words, okay, to generate default sequential values, we create sequences. Okay, in order to generate any series of numbers uh, in a default way, in a default manner, we create sequence. So in these sequences, we are going to use two functions, next val and curve val. These two functions we are going to use after creating a sequence. So how to create a sequence? So the basic syntax of creating a sequence is simple. Create sequence name. Simply, I'm writing like SQ1. Okay. That means now what? Sequence SQ1 is created. So now I said no, after creating sequence, how to generate the sequence. So I will show you on dual table. That means our dummy table. Okay. So here I am going to print the sequence by using two functions. So curval and next val. So first I will run curval. We will run and see. So actually curval function will not get initialized at the beginning because in order to generate a sequence initially we need to use a function called next val. Then only curval gets valid. Why? Because we not even generate one value in the sequence. So that's why current value you will not get anything. Okay, you will get some invalid value. So before running curval, we will run next val to start generating the sequence. Got it? So now our sequence got generated. So we created a simple syntax, create sequence name. So by default, our order starts from 1 and there is no limit. It go on generating by default incrementing 1. Okay. Now, so now I generated next val. So if I run the next val, if again I run the next val, so what happens? The next value gets generated. If again 3, 4, like that way, the sequence goes on generating the sequential order. But curve value gives at what position, what is the last generated value by the sequence. So that sequence can be given by using the curve value. That means now you can know our sequence is at which level? It is at 4. Okay. Once if you start again generating, our sequence go on increase. So now if you check the curve value, now it will change it to 5. Why? Because we are at the fifth number. Okay. Now I will show you generally where we use sequence. A small example I will show you. Okay. Simply now I want to create a table. To create table some T2 underscore EMP. Okay. Simply Two columns I want to keep. One is ID, number, and the employee name I want to give. So simply ename varchar2 data type of some 30 characters I'm giving. A small table with two columns I created. Now our table is created. Now generally I want to insert data. Insert into, generally how we insert data? Simply insert into table name, values, okay, values, and we will give the values. For example, if I want to insert first employee, okay, simply I will write the numeric ID and the value. Why? Because the two columns I'm generating. But here, instead of giving this series manually, I will do what? I will use the advantage of sequence. So for this table, I am going to create a sequence. Simply, I will create a sequence with the name called TMP underscore SQ. That means what? This table sequence like that way for identification purposes I created with the name of this. So now instead of one, I will do what? I will keep what here? I will simply keep sequence dot in order to start generating what we need to give next one. Okay, so now see, now I no need to bother about the next value also. Why? Because I go on inserting the data by using this sequence. I just change the other name, Rajesh. Okay, and if I run it, yeah. So I am go on writing the insert statement, but I am not bothered about my ID column. Why? Because I made it default now by using a sequence. Okay, so now the other number I am writing power. Now if I start inserting, it got inserted. So I said no, for every insert we need to commit. Okay, so I am just committing our insert statements, and then I will check the table, our T2 underscore EMP. Now see, now no need to worry about my sequence. It always gets generated without repeating, because sequence we created to generate sequential values one after the other. If any new employee added, automatically the next value get populated as ID to him. So no need to worry about this column. It will be always unique. Why? Because I am using the sequence. Okay. So I have shown you a basic sequence creation, but actual syntax of sequence I'm going to build now. So now you got an idea what is the use of sequence. But now how can we create sequence? So there are many options in sequence that I will show you now. Okay. Now simply I am creating one more sequence. For example, with the same table name I am creating one more sequence. SQ2 I will keep, or 2 I will keep. Okay. See, what is the basic syntax? Create sequence, sequence name. But here we can give when to start, at what point my sequence want to start. So I can give that start point also. For example, I'm giving here, see, start with the 4. That means my sequence will start not from 1. Now I am restricting the sequence to start from 4, the new sequence. That means by using which keywords we wish to write that, start with 4. And again the syntax, increment by. You can also give your own increment. I want to increment by 2 instead of 1. So I can give increment by 2. So again, We can also give max val and min val. See, I want to generate up to some level and I want to repeat the transaction again. Okay, for example, here I am keeping 12 max value and min value I will keep 1. See, actually I start with 4, but I am keeping minimum value 1. That means here one more option we will be having, that whether we want to run the sequence in the cycle manner or not. Okay, that I will show you. And so in order to run this cycle, we need to use a cache memory. Okay, so how this cache memory gets calculated is nothing but okay, simply I am keeping 2 cache. Okay, yeah. So now I will run this code and show you. See, so now if I run this command, my sequence 2 gets created. Okay, now I will show you how this sequence is getting generated. So how to generate? Next val function you are using from dual table I am showing. Now see, I said no. I said my sequence has to start with 4. It started. Increment by 2. Now again, if I run my next val, see. So after 4, 6. Again I am running. 8, 10, 12. It reached our max value. Okay. Now if I run again, what happens? You see. See, it went to 1. Okay. That means what? Here I have written what? Cycle. Cycle means what? Once it reach max value, this sequence again start from the beginning. But here I said the minimum value should be 1. So that's why next time it is not starting with 4. It is going with 1. And now see, again 2 increment. Now 3 comes, 5 comes, 6, 7 comes. So now it has been changed. Got it? So here the basic syntax of sequence is, can write start with, increment by, max value, min value. You want to run in the cyclic order, you can write cycle. Otherwise, no cycle option is also there. That also I will show you. But cache memory is like you can keep by default 2. So generally, what is the maximum cache you can take is max minus min by 2. That means, for example, here you can take cache up to 12 minus 1 by 2. So what is the 12? 11 by 2. So 11 by 2, you need to round the value. 11 by 2 means 5.5. So you can take for this maximum of 6 cache. Okay. So this is not required, but by default you can take 2 cache. Cache is nothing but it is a memory in order to cyclic. For cyclic or no cycle purpose, we will add the cache. Okay. I will show you one more example with no cycle. So here I will change. Simply start with 1. Okay. Increment by 2. Max value I am taking simply 6.
This functionality can be used for generating such kind of like employee number kind of thing.
Yes, you can use
Whenever
anywhere.
a new employee is joining, the sequential employee number can be generated.
Yes, yes. See, for example, you want to start with some 5-digit number. You can start with like this way. So that means you want to make your ID card number with 6 digit. Is it? So if you keep any number starting, so the you it will generate from there actually. So for example, here see, 1. So now I want to increment by 1 from here, and simply, actually, generally we will not keep min and max in real time. Why? Because sequence is like it has to generate. Okay. So this command only we will regularly use. That's why I have shown you this one. But there is a concept, that means there are some options in sequence that you can restrict the flow. That means you can change the flow based on your requirement. So that's why you are writing this thing. So for example, I want to generate it till 06. Okay. And no cycle if I keep means what? You are just allowing up to these numbers only for the ID number. For example, I'm saying. Okay. If you give no cycle means what happen? You just see. And minimum value also I'm just trying to keep the same number here. Okay. And now see, now if I run this one, our new sequence gets generated. So now see, now we will generate that sequence by using what? How to generate the sequence? Simply sequence name dot next way. From simply here I am using a dual table to show you how the values are generated. See, it is starting with 1002, third employee, fourth employee, fifth employee. Now 6 came. If I again run it, you will get an error saying that you have reached the maximum value, and there is no other generation. Why? Because here you restricted the flow saying that no cycle, because you have given the minimum value no. And if you keep a cycle, it again start from 1001, 100001, but it not start. Why? Because you have restricted the flow by saying that no cycle. Okay, these are the options there in sequence, but in regular aspect will not come across these things. Will simply go with the normal sequence, but here we can restrict the start. Like I want start with some 5-digit number. You will start with that number and you will create. Got it? Or if you want to increment by any other number, you can also give it. Okay. So no need to write all the options in one query also. If you want see, simply I want to write only unlimited sequence with this number increment by 2. I can end this query like this way. That means with this option. Now my sequence 4 get generated. Got it? And my sequence 4 is what? It is an unlimited sequence. But it is starting with what? This value. Incrementing by what? 2. Now you run and see. 3, 4. It will go on. Okay? There is no end for it. Why? Because you did not give max value, min value. Clear? So this is about sequence. Sequence is nothing but it is also a database object which is used to generate a order of values. Okay, which can be useful mainly in generating a default value in a column. Okay, clear now? So, and next concept we will see is indexes. Indexes. So indexes are nothing but so generally it is similar to our book index. So if you have index to search any topic, it is easy to search, is it? So if a book is having an index, it is easy for us to search that concept by pointing to a page number on the index. We can easily get the search. Otherwise, what happens? We need to turn every page and see every page and search for that topic. So generally we create index to increase the query performance. So first aspect is this. So we create indexes to increase query performance. Okay, perform. So in fetch aspect, that means your query can fetch the records faster if you create an index. So generally you create index on most frequently, okay, most frequently filtered, that means most frequently used columns in filter aspect. That means what? If you are using columns in where condition, that means for filtering purpose. So on such sort of columns, we will mainly create index. Why? Because we are searching with that column value. So we need to have index on that column. Is it? That only no. If you are searching with that column means we need to create the index on that column so that that search will become fast. Okay. So that is all I am saying. So indexes are nothing but it is similar to our book index only. But here in database, we are going to create an index on such columns. So most frequently used, not on all columns. There will be multiple columns in the search as well. But most frequently used column only we will search. We will create an index. Got it? So we will see the types of index. Okay. We'll see the types of index and we will see one by one about the syntax of index. Okay. So first I will list out all the types of indexes. So, so there are so many types of indexes which we come across in database. So first one, B tree, B tree index. So B tree is nothing but binary tree. So this this index we generally create on less duplicate values. That means if the column is having less duplicate values, we are going to have this B tree index. Okay. And next one, bitmap index. Bitmap index. So this index we create on more duplicate values. That means if the column is having more duplicates, like for example, gender column. In gender, we will see only two values mainly. Okay. So in that such sort of columns, eh, we will create an bitmap index in that column, on that column. Got it? And next one, unique index. The name itself says you are going to create this index on unique valued column. That means unique values. So we'll just create this index on unique column. And next one, functional index. So if you are using any functions in filter, for example, substring of some substring you are mapping with some value. So you will create a index on that function so that that fetch will get increased faster. So this is called functional index. I will show you the syntax, but just simply I am listing it. Okay. So mainly what we see, B tree, bitmap, unique, functional. And the special index is cluster index. I said no clusters. So cluster is a special case. So special case index. I will let you know how we create it. Okay. So these are the indexes. Okay. Now we will see the syntax of how to create a index. So create index, index name. So what is the syntax of creating the index? Simply create index, index name. So for example, IDX on. So for example, before creating an index, I will create a, so we are already having some table. No, I will just take E1 underscore EM. Yeah, this table is there. Okay. So now I want to create an index on this table. On which column I want to create? For example, job column or so now we will take the example of a B tree index. So for example, on ename column, I am going to create. Okay. Or job column you treat. Job column, I want to create an index. So how to create an index? Simply create index, index name on the table name we will write. So in brackets, we are going to write of which column. So job. So now see, so T1 underscore IDX I am going to create. Okay. Now see what? Index T1 underscore IDS get created. Okay. So this syntax is for a B tree index. So we are not using any keywords in this creating index. We simply wrote a syntax what? Create index, index name on table name of the column. It means on which column you are going to create this table job column. Okay, clear? And next one, just I will show you the syntax. So performance wise, I will show you in depth when I am saying performance tuning. But just now I will cover the syntax and then we will see performance point of view when I am saying performance tuning. Okay. So here now creating a bitmap index. So here for bitmap index, we will use a keyword bitmap index. So bitmap index and index name. So on which column generally we create bitmap? On more duplicate columns. I said no. So B tree is for less duplicates, but bitmap generally we use for more duplicate. For example, like gender or if you are using any flags, yes or no flags. So such sort of columns you are using regularly in filtering purpose. So then you create an index called bitmap on that sort of columns. So that index what we call bitmap index. So create bitmap index name p underscore idx on simply here in this table, I am just treating manager column as duplicate column. More duplicates it is having because we have only three to four managers. So I am going to create bitmap index on manager column, MGR column. Okay. Now see. So bitmap, see, for bitmap index, automatically we are getting bitmap index create. And next one, what we said, unique index. So how we create unique index? The same thing. Here we use unique, but unique, the name itself says on which columns we can create unique. So on unique columns, we can create index. So in our table, our employee number is what? It is always a unique. So that's why on such sort of columns, we are going to create what? Unique index. Okay. Okay. Here I need to change the name for something like u underscore idx and okay. Our unique index get created. Okay. And next coming to functional index. Functional index. So functional index like if you are using a functional column, for example, C for EMP, EMP or E1 underscore EMP. So regularly I am using in where class. So this function, for example, substring function I am taking. Okay, substring of employee name. Sorry, employee name not. I will take like job column. Job like 1 comma 3. So I want to CLE. That means every time I'm using this function for filtering purpose. Okay, so this will give you what generally clerk job only it is going to give. But instead of giving job equal to clerk, I am using this function regularly. So I will create a index on this function. So it will minimize my perform. That means it will minimize my fetching time and increase my performance. In the same way, for example, if you are using a length function, you are calculating some length of any character. Okay, so length of e name, you want to take the people who are having 5 length. So this, so there are this many people in 14 record. There are 9 people with 4 characters, 5 characters. So this function you are regularly using. So then you are going to use which index? Create index. So for functional index, there is no keyword, simply normal index only. So f underscore idx on which table we are creating? T1 underscore emp. And you need to write the whole function. Instead of column name, you are going to write function of that column name. And now see, your f index, functional index get created. Got it? So in this way, we are going to create indexes on the table. So as of now, you just keep in mind that if you create an index, okay, generally our index minimize the fetching time. Okay. So in performance tuning, I will go in depth with index. So how it works. Okay. But as of now, just what are the types of index and what sort of data we are going to create the index, that only keep in mind. Okay, because we are just talking about database objects. But performance point of view, index is also one concept in performance tuning. Because by creating indexes also, we can increase the efficiency of any query. As a developer, we need to know indexes on performance point of view also. Okay, that we will discuss when I am saying performance tuning topics. Okay, now going to the
Yes.
last one, cluster index. Okay, cluster index. So this is a special index I said. Okay, so how this cluster work is? So it is like just writing. It is a process. Okay, it is a process of storing one or more. Okay, one or more table values in the same block. It means in the same memory block, we are going to store a table value. Okay, I will show you how it works also. Just hear it. We regularly will not use this, but just know it. Cluster index means what? So simply I will create two tables. Okay, so simply table, okay, table G1, serial number, and okay. So before creating the tables, okay, two tables I will be creating. Uh, like for example, yeah, A1 and B1 like that I will create. And before creating a table, we need to create this cluster block. So that cluster block, how to create the syntax is create cluster name, something like CT1 I am writing. Simply, I want to map in these two tables I am using simply a serial number column, which is the same column I am using in both the tables. Okay, for without confusion purpose, I am just creating two tables with only one column. That is also a serial number. That means what? These two tables are using the same serial number. Okay, just keep in mind that's all. So here before that, I will create a cluster memory block with the same serial number. Okay, column names can be different, no issue. But just I am focusing on the cluster. So I created a cluster. How to create a cluster? Simply create cluster name, and a normal column name and the number. Now I created two tables. One is A1 and but here while creating only you will map that my data which is going to store in this serial number should refer the cluster. So what is the cluster name? CT1. Okay, CT1 SNO. Okay, this also for the same cluster. That means what you are just mapping these two serial numbers to the same memory block. Okay, cluster is nothing but it is a process of storing one or more tables. You can use n number of tables with the same data type. Okay, here instead of making you clear, I am using the same column name so that it will be very clear in understanding the concept. Okay. Okay, maybe I'm having the same name, so I will change like AA1 and BB1. So that, yeah, now AA1 table gets created and BB1 table gets created. So now I will use the index called C. Create index name. So I am creating a cluster index now. Simply I am using ct1 dot underscore index. On my cluster, I am going to create a index. So now cluster index also gets created. So now the advantage, now my mechanism is completed. I created a cluster. My normal tables I created, but I mapped respective column with the cluster for the both the tables. And later, my last step is I created an index also on the cluster. Clear? So now you see what happens. Now I start inserting data. Okay, I start inserting data in the two tables. Insert into AA1. Okay, values 1. Okay, So BB, okay, BB1 also I will insert with the same value. Okay. But in AA1, I will insert 2 and BB1, I will ignore 2. I will just insert 3. Okay. And now here I will insert 4 and here I will insert 5. That means I'm some values I'm changing in both the table. Okay. So now we will check our table. So once after insert, I am committing. Okay. I'm just committing it. Now see the tables with data. What is our table? AA1. So with what? 3 values. And BB1. Okay. 3, 5, and 1. That means these are the values actually. AA1 value is this one. This one. So I said no. What is the cluster? What cluster will do? It is a process of storing one or more table values in the same memory block. So that how can we recognize? So I said you row ID concept. Row ID is what? It is unique entire in database. I said you. When I am saying pseudo columns, I said you that row ID is nothing but it gets generated when our data gets inserted. Is it? So now see, simply I will take all the data with row IDs. Okay, of AA1 data. I'm copying here only. Okay. Now BB1 table also I will just bring that row IDs. Okay. So now here comes the cluster picture. See, in both the tables, what is the common number? 1. Is it? 1 is common, but other two numbers are different. Got it? See, now here 1 is there. So what is the value of 1? AA and AA. So I am just copying the above AA value beside this. This value and this value are same actually. See. It means cluster helps you to save the memory because 1 is same in both the tables. Why to keep that 1 in two separate memories? Just the cluster value is referring both the tables. See, this value and this value exactly same, but tables are different. But you compare with other numbers, 4 will not match. The 4 number is different and 3 number is different. See here DAA is there. Here BAA is there. But compared to 1 in both the tables, both are having same row ID. That means what? Both are mapping to the same value one. Is it? Now I will insert 4 in BB1. You see the difference. Now I'll try to insert what? 4 in which table? BB1, which is not there till now. So what is the value of this column? Serial number. Yeah. So I can directly give values, and simply 4 I will insert. So now see, I inserted 4 and I am committing it. Now you check the same query I am running BB1. Now you got the fourth value. I'm just copying this value after this value. And now you copy this value and beside the AA1 table and see. See, this value and this value are both are same. That means if both the columns are having the same numbers, that same numbers will store in the same memory block. So that is the usage of cluster. So this will save your memory as well as the efficiency of the query. Is it clear, Prashant, about this, Pawan? Now you understand
Yes.
cluster?
Yeah, bro. Understand.
Okay. Okay. So these are about different types of indexes, but we will go about performance aspect in performance tuning. But coming to indexes, how we create a normal index and a cluster index, and what is the mechanism behind the cluster index in detailed way we have discussed. Huh? You just go back and see the video again. If you miss any point, it will be clear. Okay. So these are the database objects which we commonly see in Oracle DB.